This is Note 6.1, Part 2, Solving Systems of Equations by Graphing. Objectives are to find a solution to a system of linear equations by graphing, to verify a solution to a system using the equations. Two or more equations put together is a system of equations. The symbol is this brace here to signify you have a system of equations, or basically the equations to two lines. The solution to a system of linear equations is where the lines intersect. That means that that point will make both of the linear equations true, and they are part of that line. So to find a solution to a system of linear equations by graphing, you graph the lines carefully, then approximate the point of intersection from your graph. Your solution must make both equations true. So after you graph, you will find a coordinate point with the x and the y, and then substitute into both of the equations in the system to make sure it makes true statements. All right, so the directions for the examples below are to find the solution to each system by graphing, then verify your result with true equations. The solution to these examples will be integer coordinates. That means there will be no decimals or fractions. Yay! So for example 1, we have these two lines are in slope-intercept form. The first line, when we graph, we are going to begin at -3. On the y-axis. So 1, 2, -3. And its slope is 1. It's a sneaky 1 here, which means the slope is a 1 of a rise and a run of 1. So up 1 to the right 1, up 1 to the right 1. But if you want to get fancy, down 1 to the left 1. I encourage you, when you're graphing systems, to always draw your line as you draw the dots. Don't wait until you have the two line dots on there. The second one we're going to graph in red. So we're going to start at 3 on the y-axis. 1, 2, 3. And it has a slope of -2. So that means a rise of -2, down 2, and to the right 1. Down 2, to the right 1. Down 2, to the right 1. So we can clearly see that our point of intersection is in the fourth quadrant. Draw your line. Now we have to determine the coordinates that these two lines intersect. We start at the origin to find the coordinate points, and we go 2 to the right, which is a x-coordinate of 2, and a down 1, so it's a -1. So our coordinate point is 2, -1. To verify, we simply substitute in the x and the y into both equations to make true statements. So here it's -1 is equal to 2 minus 3, which absolutely equals each other. Also, taking this point, here's a -1 is equal to -2 times 2 plus 3, which gives you a -1 is equal to -2 times 2 is -4. -4 plus 3 is also -1. Now we have verified using our algebra that this point is on the line. Example 2. We're going to begin this blue line at 2 on the y-axis. We have a slope of +2. So up 2 to the right 1, up 2 to the right 1, or fancy, down 2 to the left 1. Draw your line and move on to the next line. In slope-intercept form, we begin with the y-intercept of 5, and we have a slope of 1/2, which means there's a rise of 1 and a run of 2. A rise of 1 and a run of 2. Or if you want to be fancy, down 1 to the left 2. Draw your line. And we can see our intersection is here in the first quadrant. The x and y coordinates starting at the origin is 1, 2, 3, 4 in the x direction, and 1, 2, 3, 4, 5, 6, 7 in the y direction. Oh, I'm sorry. Scratch that. It is 2 in the x direction, and 1, 2, 3, 4, 5, 6 in the y direction. You got to get your coordinates right or it won't make those equations true. Substitute in 6 is equal to 2 times 2 plus 2, and that is a true statement. 2 times 2 is 4 plus 2 is 6. Yeehaw. Now, this one, substitute 6 in for y. 1/2 times 2 plus 5. 6 is equal to 1/2 of 2 is 1 plus 5 is also 6. So we have verified using algebra and by graphing. The last example we're going to do together, we're going to start at 1 for our first line. And it has a slope of 1/2. Up 1 to the right 2, up 1 to the right 2. Our second line, beginning at -5 on the y-axis, 1, 2, 3, 4, 5, -5, and then up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. I like to do the dots until I can see exactly where those two lines cross. Sometimes with graphing, if your lines aren't perfectly graphed, you could be off a little bit, so it's hard to tell what your integers are that they are intersecting at. So our x-coordinate is 1, 2, 3, 4 in the x direction, and 1, 2, 3. Whew, got that right the first time. Substitute in, we have 3 is equal to 1/2 times 4 plus 1. 3 is equal to, half of 4 is 2, plus 1 is 3. And our second linear equation, we're going to substitute 3 in for y, 2 times 4 minus 5. So therefore we get 3 is equal to, 2 times 4 is 8, 8 minus 5 is also 3. So we have verified all of these systems of equations by graphing and algebra. Please proceed to the examples on the back.